a particle is initially at the origin and moving to the right at 5 meters per second. It accelerates with time according to AT, so acceleration as a function of time, equals 4 minus 2t centimeters per second squared. So this is a non-calculator question. We need to A, find the velocity function of the particle and sketch its graph for a domain of time between 0 and 6 inclusive. And we need to, for the first 6 seconds of motion, determine the displacement of the particle and the total distance travelled. So there's quite a lot of information in that first bit actually. It says a particle is initially at the origin. So if you just look at that bit, that is telling us that S0 is in the original position equals 0, is initially at the origin. So that's a useful piece of information straight away. It's moving to the right at 5 meters per second. So that's telling you that V0 is 5 and it's positive because it's going to the right. So equals 5. So already 2 useful pieces of information. Accelerates with time according to AT equals 4 minus 2t. So AT equals 4 minus 2t. We have been asked to, part A, find the velocity function of the particle and sketch its graph. So to find the velocity function, we're going to need to integrate the acceleration function. So Vt equals the integral of at dt. So 4 minus 2t dt. Okay, which is quite nice. That's just 4t and then minus 2t squared over 2. So that's minus t squared plus the constant of integration, right? So now we can actually find this constant of integration because we have this boundary condition. We know that when t equals 0, vt equals 5. So we know that 4 times 0 minus 0 squared plus c equals 5, which just means that c equals 5, which must mean that vt equals 4t minus t squared plus 5, just like that. So if we want to sketch its function, then really we need to look to find some zeros. So we're probably going to try and factorize this thing. So if we know this is 4t minus t squared plus 5, I'm going to call that, so vt equals minus, it's always a lot easier to factorize things if you get rid of, if you don't have a negative square term. So t squared minus 4t minus 5. So I'll just pull the minus 1 out as a factor. So if you look to factorize that, 5 and 1 will make 5 when timesing, and they can make minus 4. So that could be minus and t and 5 and a t and a 1. And as I was saying in this bit, the 5 needs to be negative and the 1 needs to be positive. So at that point you could potentially you could put that negative back into one of the brackets, but to be fair, I don't really, for what I need to do, I don't really necessarily need to do that, because all I'm interested in, I need to sketch the graph. So I need to know, well, I already know that it's basically a negative quadratic because the t squared term is negative, and I need to know the roots. So the zeros are at 5 and 1 are zeros, so minus 1, zeros. But we're sketching the thing from 0 to 6. So the graph of this would have a 0 at minus 1 and at 5, like that, and it would sort of do something like that. To 5, but because we've only been asked to sketch the thing from 0 to 6, we're basically chopping off this bit. and we know that this value is 5. So basically our graph is just going to look like this. So we're going to have the y-axis, we're going to have this starts at 5, this is t on this axis, and then it goes up to 5 here, and then it just sort of goes up for a bit, and then it goes down to 5, and actually because I've been asked to sketch it to 6, there's going to be a bit here when the area is kind of negative, so I'll just extend that a little bit, and then we're going to 6 there. So this is VT, and how it varies with t, so just like that. So for find the velocity function, we've got that, sketch its graph. So I think that's okay. I need to tell it that that's 5. I wouldn't worry about this maximum. That's not really particularly relevant for the rest of the question anyway. This is a good enough sketch. Right, so the next bit, for the first 6 seconds, determine the displacement, so as in from start to finish, as in from time 0 to time 6, what's the difference in position that that particle has. So that's the first bit, and then the second bit, I need to determine total distance travelled. So that is when we need to decide, well, which direction is the thing going in, because once you have a negative velocity, as in this area in here, once your velocity is negative, it means that the thing's going backwards. So we are going to need a displacement function. So this is now part B, and we're going to need s of t. So that's going to be the integral of vt dt. So the integral of 4t minus t squared plus 5 minus t squared plus 5 dt. So that must be 4t squared over 2, which is 2t squared, minus t cubed over 3 plus 5t, and then we're going to bring a new constant of integration in. Right, but it shouldn't be too bad, because we know that S0, if you recall, it started initially at the origin, so we said that S0 was 0, so S0 equals 0, which must mean that, well, 2 times 0 squared minus 0 cubed over 3 plus 5 times 0 plus c equals 0, so it just means c equals 0, which means that s of t must equal 2t squared minus t cubed over 3 plus 5t. Right, so I might just draw a little sign diagram for v, but it's not, the graph's got enough in it, so you know that we start at 0, everything's positive here, so this velocity, the fact that it has this maximum, that's not a change in direction, that's about acceleration, we don't need to worry about that. All the time when it's above the x-axis, this velocity is positive, which means it's moving to the right. So it's positive in here, and then it's only after 5 that we have a negative velocity, just like that. So what I need, the key points we are interested in are S0, which we already know is 0, sorry, S0 equals 0. Try and change it, see if I can get a little bit more ink out of this pen. I'm going to need S5, which is not going to be so easy, unfortunately. So S5 is going to be 2 times 5 squared, which is 2 times 25, which is 50, minus 5 cubed over 3, well, 5 cubed is 125. Does 3 go nicely into 125? No, not really. So 125 over 3, we'll leave it like that. Plus 5 times 5 is 25. So that must be, well, 125 over 3 could be 120 divided by 3, which is 40, plus 5 divided by 3. So that could be 41 2/3. So that's 50 plus 75, 75 plus, we just said that was, sorry, minus 41 2/3. So S5 must be, so 75 take away 40 is 35, take away 1 is 34, take away 2/3 must be 33 1/3. So that's the position at S5. We'll do something similar for S6. S6 equals, so it's going to be 2 times 6 squared, or 6 squared is 36. 2 times 36 is 72. Minus 6 cubed over 3, or 6 sixes are 36. 36 times 6, well, seeing as I'm going to divide it by 3 anyway, I could just do 36 times 2, which is surely going to be 72 again. Let me just check that. So if I'm doing, I need to do 36 times 6, which could be times 3 times 2, and then divide it by 3. So it's just going to be 36 times 2, which is another 72, plus 5 times t, or 5 sixes are 30, so plus 30. So S6 is just 30. Equals 30. Okay, so we've got 3 key values. So for part 1, for B part 1, it's just asking for the displacement in the first 6 seconds, which is just going to be S6 minus S0, which is going to be S6 minus S0 is 30 minus 0 equals 30, and the units of this are centimeters. For B2, it is asking us for the total distance travelled. So the total distance travelled, well, you've got the bit between 5 and 0 is all positive, so it's going to be S5 minus S0, and then we're going to take away, because this is the other bit between 6 and 5 is going to give us a negative velocity, but we're just interested in distance travelled, so I want to add that as a positive, because I know it's going to come out negative because it's below the x-axis. So I'm going to do minus, and this is going to be S6, 6 minus S5. So just have a quick look at it. Is there anything good that happens, e.g. a cancelling? S5 minus no, not really, but what I could do, I could say, well, S5 minus S5 is 2S5 equals 2S5 minus S0, well, that's, I could just, I mean, it's just 0 anyway, but let's put it down, minus S0 and then minus S6. So we've said S5 was 33 1/3, so 2S5 must be 66 2/3, so this must be 66 2/3 minus S0, which is just 0, minus 0, minus S6, which I think was 30, minus 30, so the final answer must be 36 2/3 centimeters travelled in total. 36 2/3 centimeters travelled for the whole journey in total. Just put a box around.